Hi guys, in this video we would like to understand the first important control of JavaFX programming, that is label. Label is a passive user interface control which is used to the user to interact the JavaFX application. Label is a simple user interface control. A label contains non-readable text that is used to displaying text for some other control's identification. Label control is defined in JavaFX.scene.control package, and the parent class for label class is a labeled class. While understanding any JavaFX user interface control, we would like to understand the constructors of that particular user interface control, and we would like to understand the important methods of that respective user interface control. First, we would like to understand constructors of label user interface control. There are three different constructors which are defined in label class. First constructor is label without having arguments. It creates a label control without having any name. The second control, label with string argument as argument of label constructor, which creates a label with respect to text, that is act as a label text for the label control. And next constructor which contains two arguments, one is a text argument, second one is graphic argument, that is used for creating a label not only with the text message, and we can able to add graphic also. That means we can able to add image also. So how to add image to the label control we will understand in coming videos. Next, how to add label to scene graph. That means suppose if any control is created, adding that control to the scene graph which is not directly possible, we would like to add that control to the observable list of respective pane class. When any control added to that respective controls observable list, the respective pane class observable list, automatically the control is added to the scene graph. When control is added to the scene graph, automatically it is added to the scene component of the JavaFX application. So in order to add that respective control to the observable list, first we need to get the observable list of that respective scene graph. How to get the observable list of respective scene graph is by calling getChildren method. The getChildren method which is invoked from pane class. The syntax for getChildren method is observable list, generic argument as node, and getChildren method. Observable list, node, getChildren method. So this method is defined in pane class. Every inheritable class of pane class which is inherited with this method is called through either flow pane, either grid pane, either vbox, or either with the hbox. So with any pane object we will call this getChildren method in order to get observable list. Once after getting observable list, to the observable list we will add user interface controls. In order to add elements to observable list, we would like to understand important methods of observable list. The methods are similar to list methods defined in java.util.list class. There is similarity between java.util.list class in java.util package and javafx.collections.observable list from javafx.collections package. The similarity is both for adding elements to list component. The difference between observable list and list object is observable list which tracks whatever the elements are added to the list, and list doesn't tracks the element, it just add the element. The observable list also a The observable list also a class which is inherited from java.util.list class. The methods defined from observable list are: first method is add method. Suppose if you would like to add one object to observable list, call add of object method. Suppose if you would like to go for adding multiple elements, call add all of, specifying multiple elements, multiple objects separated by comma. The object what is added to observable list, if you would like to remove such element, call remove method by specifying that object created. Suppose if you would like to go for removing all elements, the objects whatever to be deleted, specify that object's name. Whether the object addition or object removing is successful, it returns the boolean value true. Whether true is returned, that operation is successful. Whether false is returned, while going for adding or removing, that operation is unsuccessful. The demonstration for label control we would like to understand with hands-on practice. Let us open a notepad++ editor, take a new file. It is a, we will title the program as labelfx demo.java. Then save the program as labelfx demo.java. Save the file as Java source file. Now import all packages. Import JavaFX dot application. Import JavaFX dot stays. Next, import JavaFX dot scene. Next, in order to work with the layouts, import JavaFX dot scene dot layout. Next, in order to work with JavaFX controls, JavaFX dot scene dot control. Next, in order to work with colors, call JavaFX dot scene dot paint. In order to arrange graphical interface controls on specific locations, call JavaFX dot geometry package. So this is the way the required packages are imported. So next define a public class label fx demo extends application. Next, go for defining start method, stays st, throws exception. Next, go for creating a flow pane object. Flow pane fp is equal to new flow pane. The flow pane arranges components in horizontal manner. Next, to create a 4 different labels. Labels L1 is equal to new label AITS Rajampet Next create the second label. Label L2 is equal to new label AITS Kadapa. Next create another label. Label L3 is equal to new label of AITS Hyderabad. Next create another label. Label L4 is equal to new label of AITS Tirupati. This is the way four different label components are created. Now we would like to add these labels to observable list. In order to get observable list, we have to call the getChildren method from flow pane, then call addAll method, addAll of L1, L2, L3, L4. Next, set the alignment for all labels what are created on the flow pane on the scene graph to the scene. Call set alignment method in order to position different labels or any controls on the scene. Call constant from position class position dot top bottom. There are different constants are defined in POS class. Such constants are top bottom, left, top left, top right, center left, center right, bottom left. Like that, there are different constants are defined where we would like to arrange the we would like to arrange the components. That constant name we have to refer here. Next, we would like to go for creating scene object. Scene S is equal to new scene of flow pane object come. Next, specify the horizontal width, vertical height. Then go with adding of scene to the stage. Set scene of scene object. Next, st dot set the title label demo. Next, suppose if you'd like to add color, call set fill also color dot blue. This is the way to the stage. Scene is added, title is added, and background color also added. Now we would like to call the show method in order to present the show from JavaFX stage. Next, close the start method. Next, define the main method to launch the application. Of course, this method is optional method. It is not necessary to define. JavaFX application when is loaded into the JVM, automatically it calls the lifecycle methods. Finally, it calls the launch application. Launching of JavaFX application is automatically happen. After launching of application, it calls the lifecycle methods in order to execute first it will go for execution of init method. If the init method is available, the available init method from our respective class is executed. If init method is not defined by our class, it is executed from by default method defined from the application class. Next, start method is executed from our class. When application is closed, automatically the stop method defined from our application is executed. If we are not defined, the stop method is executed from application class. This is the way we define label fx demo application. Now we would like to compile for this application JavaC label fx demo.java. We got errors. We would like to check out what is error is happened. I think we refer top bottom, not it is a top bottom, it is a bottom left to bottom right to, likewise top left to top right to, center left to center right to right. Now again we go for controlling the next color. We doesn't add color for stage. We will add color for, we doesn't add color for here. I will remove this. Now we'll compile the program. It is successfully compiled. Now we'll execute the program. Okay, so labels are created like here. ATS Rajampet, ATS Kadapa, ATS Hyderabad, ATS Tirupati. So there is no gap which is maintained between all these different labels. We can add a space also by calling from, while creating flow pane object, by specifying horizontal space and vertical space. We can maintain the space also. Next, we will take the top center. Instead of bottom left, we will take center. Now again we will compile the program. So this is the way the labels are displayed after modification. Now from each control, horizontally 20 pixels and vertically 20 pixels of space is maintained from each component. So this is the way we are adding 4 labels. In this way we can demonstrate the labels. This is the way, by changing respective changes what are required, we can able to present label component. This is about label demonstration. In the next video, we would like to understand how to work with button control. Thank you for watching my presentation.